So now that we've been introduced to some polar curves and graph in polar coordinates, we're now going to move on to slopes of tangent lines in polar coordinates. So I will ask you to recall with me the slope of a tangent line we obtain by finding specifically the derivative of y with respect to x. Now, back in the parametric section, we also said that if you can define x and y parametrically, then you should be able to take dy over dt and dx over dt, assuming that t is your parameter. Well, what we just saw is that in polar coordinates, x can be expressed as r times the cosine of theta, and that y can be expressed as r times the sine of theta. But if you're also given r as a function of theta, then really what you're looking at is a function of theta times the cosine of theta and a function of theta times the sine of theta. So what you can do is treat theta as your parameter and differentiate each of these using theta as your parameter. So with that in mind, dx d theta would be equal to, from this formula here, we'll need the product rule. So first times derivative of the second plus the second times the derivative of the first. We'll call that dr d theta. dy d theta is going to be equal to, from this formula, the first, which is r, times the derivative of the second, which will be cosine of theta, plus the second, sine of theta, times the derivative of the first. That'll be the derivative of r with respect to theta. So making use of this formula, but treating theta as though it's your parameter, we would get the following. dy dx is equal to dy d theta, so r cosine theta plus dr d theta times the sine of theta over dx d theta, which will be negative r sine theta plus dr d theta times the cosine of theta. You absolutely should not memorize this formula. There is a much more straightforward way to calculate these derivatives. I'm going to demonstrate in an example in just a moment. Now, same thing is true here as was true for parametrics, which is that if dy d theta is equal to 0 and dx d theta is not equal to 0, what you're saying is that x is not constant while y is constant. That would be an example of a horizontal tangent line. Tangent is horizontal. Whereas if we were to say dy d theta is non-zero while dx d theta is equal to 0, what we're saying is that x is not changing while y is changing. That would be an example of something that is vertical. So tangent is vertical. On my next video, I'm going to demonstrate one of these derivatives and take a look at it.